Hello and welcome again to some science and principle questions. It's question 3 this time, so let's have a look what it says. It says, a voltmeter, an ammeter and wattmeter are arranged to measure power in a single phase circuit. Show how these instruments would be connected and calculate the circuit power factor if the readings were 16 amp, 240 volt and 3600 watts. Okay, so we'll start by drawing a circuit. That's a sensible way to start. Now it's got a power factor. I'm just going to guess and say it's an inductive load. I don't know. Could be capacitive. So where would we measure voltage? Well, voltage is a measure of the difference in potential. So we need to go from the live side to the neutral side. We need to see what that difference is. So the volts would be across the circuit, so in parallel we'd call it. The ammeter, well, that's a measure of, how much current is passing one point at one time. So that has to get in the way and see how much charge is flowing past its sensor, if you know, coil, and measure how much the intensity is of that current. Power, it does both. So it's working out measuring the voltage, measuring the current, and then timesing the two together. So it goes there and gets in the way to measure the current, but also it goes across and measures in parallel for the voltage. So that's how these things would be connected. Now we've got some readings there which are quite handy, and what we're going to need to understand is our power triangle for this. And the labels of that triangle are as follows. And this, just like it was in the last question really, the cosine of this angle is power factor, because the relationship between resistance and watts, that's the same. Inductive reactance, reactive power, that's the same. And then you've got the total there. So the impedance triangle, which is that. These are all related. And, if you can get your head around how they're related, you're in a really good place to understand circuit analysis, really. But we said on the last video that, this is just trigonometry, and we're going to use the same thing again. So it's asked us to work out the power factor, which we know is the relationship between this side and that side. Just like in the impedance triangle, if you had no inductive reactance, we said that you wouldn't have an angle there because it would just be a straight line. And if we got no reactive power, which is this distance, if that was down here, then again we'd have a straight line and watts would equal VA. But when we've got some reactive power from some kind of component, then that is going to increase depending on the size of it, and this angle is going to increase. So anyway, in trigonometry, if we use the car bit, C equals A over H, then we can see that our adjacent is our watts. So cosine of the angle, which we call power factor, is equal to watts divided by the hypotenuse, which in our case is VA. So learn trig, really handy. So our watts was 3600. I'm just going to write it here. This is cosine theta. 3600 divided by our VA. Now VA is exactly what you'd expect. It's volts times amps. It's easy. What have we got? We got 16 amps and 240 volts. So 240 times 16. And we can work out our power factor. It's a nice easy one. I'm glad I chose that. So 3,600 divided by 240 times 16, and we've got 0.94. It's a pretty good power factor, so it's not a bad situation, bad circuit. 0.94. Okay. Now, would you leave it like that for an exam? Nah, I think you can tidy it up a little bit. So I would probably number these, I think, because I don't want to, this is my thought process, I've worked it all out, I don't want to undo all that, I want them to see my thought process, so let's do it like that. That was step 1, and step 2 was turning it into a kind of formula for me, and then step 3 was putting it all in, and then step 4 was my power factor. It's really good to just be very clear in your exams. It really, well, it makes my life easier in marketing, I'll tell you that. So there we go, our power factor is 0.94. To measure voltage, we go in parallel with the circuit. Current, we go in series with the circuit. And our wattmeter does both. Happy days. Question 3 done. Join me on the next one. See ya.